Welcome. In today's digital world, data is the backbone of every application and business. But how we store and manage that data can make a huge difference in performance, reliability, and cost. In this video, we'll explore the main types of database systems, relational, NoSQL, and NewSQL, and discuss how to optimize your storage strategy. Whether you're a developer, database administrator, or just curious about data, this guide will help you understand the strengths and trade-offs of each approach. Let's start by looking at why data storage matters so much. Database is an organized collection of data, generally stored and accessed electronically from a computer system. Databases are essential for managing large amounts of information efficiently. They allow us to store, retrieve, and manipulate data quickly and securely. From social media platforms to banking systems, databases power the applications we use every day. Understanding the different types of databases is key to choosing the right one for your needs. Next, let's dive into the most traditional type, relational databases. Relational databases, often called SQL databases, have been around since the 1970s. They store data in tables with rows and columns, much like a spreadsheet. Each table represents a specific entity, such as customers or orders, and relationships between tables are defined using keys. SQL, or structured query language, is used to interact with the data. Relational databases are known for their strong consistency, reliability, and support for complex queries. Popular examples include MySQL, PostgreSQL, and Oracle database. Relational databases excel in scenarios where data integrity and consistency are critical. They enforce strict data schemas, which means every piece of data must fit a predefined structure. This makes them ideal for financial systems, inventory management, and any application where accuracy is paramount. Their mature ecosystem offers robust security, backup, and recovery features. However, as data grows and becomes more complex, relational databases can face challenges with scalability and flexibility. While relational databases are powerful, they aren't perfect for every use case. Their rigid schema can make it difficult to adapt to changing data requirements. Scaling horizontally, adding more servers to handle increased load, can be complex and costly. For applications with massive, unstructured, or rapidly changing data, relational databases might not be the best fit. This is where alternative database systems come into play. Let's look at NoSQL databases next. NoSQL databases emerged to address the limitations of traditional relational databases. The term NoSQL stands for not only SQL, highlighting their flexible approach to data storage. NoSQL databases can handle a wide variety of data types, including documents, key value pairs, graphs, and columns. They're designed for scalability, allowing them to manage huge volumes of data across distributed systems. Popular NoSQL databases include MongoDB, Cassandra, and Redis. NoSQL databases come in several flavors, each optimized for different use cases. Document stores like MongoDB are great for storing JSON-like documents. Key-value stores such as Redis offer lightning-fast access to simple data structures. Column family stores like Cassandra excel at handling large datasets with high write and read throughput. Graph databases such as Neo4j are perfect for managing complex relationships. This flexibility makes NoSQL a popular choice for modern, data-intensive applications. NoSQL databases shine when it comes to scalability and flexibility. They can easily scale out by adding more servers, making them ideal for big data and real-time web applications. Their schemaless design allows for rapid development and easy adaptation to changing requirements. NoSQL databases are also well-suited for handling unstructured or semi-structured data, such as social media posts, sensor data, or multimedia files. Despite their advantages, NoSQL databases have some trade-offs. They often sacrifice strong consistency for scalability and performance, which can lead to eventual consistency issues. Their lack of a fixed schema can make data validation more challenging. Additionally, NoSQL databases may not support complex queries or transactions as efficiently as relational databases. It's important to match your database choice to your application's needs. SQL databases are a newer class of database systems that aim to combine the best of both relational and NoSQL worlds. They maintain the ACID guarantees and SQL interface of traditional relational databases, while offering the scalability and performance of NoSQL systems. NoSQL databases are designed for modern high-throughput applications that require both consistency and scalability. Examples include Google Spanner, CockroachDB, and VoltDB. SQL databases offer several key features. They support SQL queries and transactions, making them familiar to users of traditional databases. At the same time, they are built for distributed architectures, allowing them to scale horizontally across many servers. NoSQL systems provide strong consistency, high availability, and fault tolerance, making them suitable for mission-critical applications that demand both speed and reliability. SQL databases are a great choice when you need the transactional integrity of a relational database, but also require the scalability of NoSQL. They're ideal for financial services, e-commerce platforms, and any application where both data consistency and high performance are critical. However, NoSQL solutions can be more complex to set up and manage, and may come with higher costs compared to traditional options. Now that we've covered the basics, let's compare relational SQL, NoSQL, and NewSQL databases side by side. Each has its own strengths and weaknesses. Relational databases are best for structured data and complex queries. NoSQL excels at scalability and handling diverse data types. NewSQL aims to bridge the gap, offering both consistency and scalability. The right choice depends on your application's requirements, data structure, and growth expectation. Performance is a key factor when choosing a database system. Relational databases offer fast and reliable transactions for structured data, but can struggle with massive scale. NoSQL databases are optimized for high throughput and low latency, especially with large distributed datasets. NewSQL databases aim to deliver both speed and consistency, but may require more resources. Always benchmark your specific workload to find the best fit. Cost is another crucial consideration. Relational databases often require expensive hardware and licenses, especially for enterprise solutions. NoSQL databases can reduce costs by running on commodity hardware and scaling out as needed. NewSQL databases may involve higher initial investment, but can offer savings through improved performance and reduced downtime. Cloud-based solutions can further optimize costs by allowing you to pay only for the resources you use. Data modeling is the process of defining how data is structured and related in your database. In SQL databases, this means designing tables, columns, and relationships with clear rules. Proper data modeling ensures data integrity and efficient queries. However, it requires careful planning and can be less flexible if your data needs change over time. Let's see how this compares to modeling in NoSQL systems. NoSQL databases offer a more flexible approach to data modeling. You can store data in various formats, such as documents or key-value pairs, without a fixed schema. This makes it easy to adapt to changing requirements and handle diverse data types. However, the lack of structure can lead to inconsistencies if not managed carefully. It's important to design your data model based on your application's access patterns and scalability needs. SQL databases combine structured data modeling with the ability to scale. You still define tables and relationships, but the underlying architecture supports distributed data and high availability. This allows you to maintain data integrity while handling large, complex workloads. NewSQL systems often include tools to help automate data distribution and replication, making them easier to manage at scale. Scaling your database means increasing its capacity to handle more data and users. Relational databases typically scale vertically by upgrading hardware, which can be expensive and has limits. NoSQL and NewSQL databases are designed for horizontal scaling, where you add more servers to distribute the load. This approach is more cost-effective and supports massive growth, but requires careful planning to ensure data consistency and performance. Protecting your data is essential. Relational databases offer mature backup and recovery tools, making it easy to restore data after a failure. NoSQL databases may require more custom solutions, but many now include built-in backup features. NewSQL databases combine these capabilities with distributed backups, ensuring data is safe even if a server fails. Always test your backup and recovery process to avoid surprises. Security is a top priority for any database system. Relational databases offer robust access controls, encryption, and auditing features. NoSQL databases are catching up, but may require additional configuration to ensure data is protected. NewSQL databases inherit strong security features from both worlds, making them suitable for sensitive applications. Always follow best practices for authentication, authorization, and encryption. Optimizing database performance involves tuning queries, indexing data, and monitoring system resources. Relational databases offer advanced tools for query optimization and indexing. NoSQL databases focus on efficient data access patterns and distributed processing. NewSQL systems provide automated tuning and real-time analytics to help maintain peak performance. Regular monitoring and maintenance are key to avoiding slowdowns and bottlenecks. Efficient storage can save both money and resources. Techniques like data compression, partitioning, and deduplication help reduce storage costs and improve performance. Relational databases often use partitioning and indexing to speed up access. NoSQL databases may use sharding to distribute data across servers. NewSQL systems combine these methods with automated storage management. Choose the right techniques based on your data volume and access pattern. Regular monitoring and maintenance are essential for database health. Use monitoring tools to track performance, detect anomalies, and plan for capacity upgrades. Scheduled maintenance tasks such as updating indexes and cleaning up old data help prevent issues before they impact users. Both cloud and on-premises databases benefit from proactive management to ensure reliability and efficiency. Choosing between cloud and on-premises storage depends on your needs. Cloud databases offer flexibility, scalability, and pay-as-you-go pricing. On-premises solutions provide more control and may be required for regulatory compliance. Many organizations use a hybrid approach, combining the benefits of both. Consider factors like cost, security, and management complexity when making your decision. Migrating data between databases can be complex and risky. Differences in data models, formats, and features require careful planning. Tools and services are available to help automate migration, but testing is critical to ensure data integrity. Always back up your data before starting a migration and plan for downtime or rollback in case of issues. Solid disaster recovery plan ensures your data is safe in case of hardware failure, cyber attack, or natural disaster. Regular backups, offsite storage, and failover systems are key components. Relational, NoSQL, and NewSQL databases all support disaster recovery, but the tools and processes may differ. Test your plan regularly to make sure you can recover quickly when needed. Many industries are subject to strict data regulations, such as GDPR or HIPAA. Relational databases offer mature compliance features, including auditing and access controls. NoSQL and NewSQL databases are adding compliance tools, but may require extra configuration. Always understand your regulatory requirements and choose a database system that supports compliance out of the box. Database administrators, or DBAs, play a vital role in managing and optimizing database systems. Their responsibilities include installing and configuring databases, monitoring performance, ensuring security, and planning for growth. DBAs work closely with developers and IT teams to keep data safe, available, and efficient. As databases evolve, the DBA role continues to adapt to new technologies and challenges. Automation tools are transforming database administration. Tasks like backups, scaling, and performance tuning can now be automated, reducing manual effort and errors. Cloud platforms offer automated database services that handle routine maintenance, updates, and failover. Automation frees up DBAs to focus on strategic planning and optimization, making database management more efficient and reliable. Modern databases come with powerful monitoring tools and dashboards. These tools provide real-time insights into performance, resource usage, and potential issues. Dashboards help DBAs and developers spot trends, troubleshoot problems, and plan for future growth. Investing in good monitoring tools can prevent downtime and ensure your database runs smoothly. Optimizing queries is essential for fast and efficient data access. Techniques include indexing, rewriting queries for efficiency, and analyzing execution plans. Relational databases offer advanced query optimizers, while NoSQL and NewSQL systems focus on efficient data retrieval patterns. Regularly review and tune your queries to keep your database performing at its best. Indexes are special data structures that speed up data retrieval. In relational databases, indexes are used to quickly find rows based on column values. NoSQL databases use different indexing methods depending on the data model. NewSQL systems combine traditional and modern indexing techniques. Proper indexing can dramatically improve query performance, but too many indexes can slow down writes. Partitioning and sharding are techniques for dividing data into smaller, more manageable pieces. Partitioning splits data within a single database, while sharding distributes data across multiple databases or servers. These methods help improve performance and scalability, especially for large datasets. Both NoSQL and NewSQL databases often use sharding to handle massive workloads. Caching stores frequently accessed data in memory for faster retrieval. This reduces the load on your main database and speeds up application response times. Common caching solutions include Redis and Memcached. Both relational and NoSQL databases benefit from caching, especially for read-heavy workloads. Implementing an effective caching strategy can greatly enhance performance. Archiving old or infrequently accessed data helps keep your main database lean and efficient. Archived data can be stored in cheaper, slower storage, freeing up resources for active data. Many database systems offer built-in archiving tools, or you can use external solutions. Regularly review your data to decide what should be archived and what needs to remain active. Data compression reduces the amount of storage needed for your database. This can lower costs and improve performance, especially for large datasets. Most modern databases support compression, but it's important to balance compression rates with processing overhead. Test different compression settings to find the best balance for your workload. Duplication eliminates redundant copies of data, saving storage space and improving efficiency. This is especially useful in environments with lots of similar or repeated data such as backups or logs. Many database systems include deduplication features, or you can use external tools. Regular deduplication helps keep your database clean and cost-effective. Selecting the right database system depends on your application's needs, data structure, and growth plans. Relational databases are best for structured data and complex queries. NoSQL databases offer flexibility and scalability for diverse data types. NewSQL databases combine consistency and performance for demanding workloads. Consider factors like cost, performance, and ease of management when making your choice. Database landscape is constantly evolving. Cloud-native databases, serverless architectures, and AI-driven optimization are shaping the future. Expect to see more automation, better integration with analytics tools, and improved support for real-time data. Staying informed about new trends helps you make better decisions and keep your data infrastructure competitive. Hybrid and multi-model databases support multiple data models within a single system. This allows you to store structured, semi-structured, and unstructured data together. These databases offer flexibility and can simplify your architecture by reducing the need for multiple systems. Examples include Microsoft Azure Cosmos DB. Database as a Service, or DBaaS, is a cloud-based offering that handles database management for you. Providers like Amazon RDS, Google Cloud SQL, and Azure Database offer automated backups, scaling, and maintenance. DBaaS can reduce operational overhead and let you focus on building your application instead of managing infrastructure. Choosing between open source and commercial database solutions depends on your budget, support needs, and technical expertise. Open source databases like MySQL and PostgreSQL offer flexibility and cost savings, while commercial options provide dedicated support and advanced features. Evaluate your team's skills and your application's requirements before making a decision. Wrap up: choosing the right database system is about understanding your data, your application's needs, and your growth plans. Relational, NoSQL, and NewSQL databases each have their place. Focus on performance, cost, and security when designing your storage strategy. Regularly review and optimize your setup to keep up with changing requirements and technology trends. Thanks for joining this deep dive into data storage and database administration. The right database can make all the difference in your application's success. Stay curious, keep learning, and don't be afraid to experiment with new technologies. With the right knowledge and tools, you can build a data infrastructure that's fast, reliable, and cost-effective.